Chapter 7, Problem 42. We have this cart being pulled by a pulley. It's on a frictionless surface. The pulley is frictionless, massless. The cord goes over the pulley 1.2 meters above where it's attached to the cart. The cart slides from 3 meters to 1 meter. And the question is, during all of this, if the cord maintains a constant tension of 25 newtons, what is the change in kinetic energy of the cart during the move? Okay, so one of the things we've got here is we've got a force that is changing depending on x. Did not mean to erase that. I will erase that though. Okay, we have our triangle, right? This is x. This is 1.2 meters. And we have a tension force that's directed that way, and that is 25 newtons. Okay, it's 25 newtons. Apologize for that. Now, what does that mean? That means that we need to figure out I've done it again. See if I can draw again. We need to figure out the component of the force along the direction of the motion, because we don't care about the component of the force straight up. That doesn't move the box. Because it doesn't move the box, it does no work. But the component on this side is basically 25 newtons times the cosine of the angle that the cord makes. The cord goes off this way at some angle theta. Well, we don't know that angle, but we do know the length of this side. The length of this side is x. The length of this side is 1.2. We know that the cosine is equal to adjacent divided by hypotenuse. So all we have to do is calculate those. All right? So we're looking for a force which is equal to 25 newtons times the cosine of theta. All right? And we don't know exactly what theta is yet, but we can figure out the cosine. Why? Because we know that the adjacent side, right, is x long, and we know that the hypotenuse is going to be square root of x squared plus 1.20 squared, right? It's going to be the square root of the sum of the squares of the sides. And so based on this, we know what the force is. The force is 25 newtons times, okay, adjacent divided by hypotenuse. .20 squared. Okay, that's the force. That's the force on it, and as you can see, it's a variable force. It depends on x. Now, from the last few problems, they're asking for the change in kinetic energy, which is going to be the work, which is going to be the integral from, where do we start off? 3 meters, right? From 3 meters, no, yes, 3 meters to 1 meter, okay, all right, now, one other thing, because this force points in the negative direction, I have to put my negative in, right? So 1 meter, from 3 meters to 1 meter of minus 25 newtons times x divided by square root of x squared plus 1.20 squared dx. Okay, so that's the integral we have to do to find out how much work was done and what the kinetic energy of this block, what the change in kinetic energy of this block is. All right, so step one, I'm going to pull the 25 out, and I'm going to go ahead and say the negative sign simply reverses the order of integration, and now we have x divided by square root x squared plus 1.20 squared dx. Okay. Now, if you look in the front of your book, there's a very small table of integrals. We're going to do this one with a substitution. The substitution we're going to use is u equals x squared. Now, if I make u equals x squared, then du equals 2x dx. All right. Now, if u equals x squared, then we can rewrite this as 25 newtons. Now the limits. The lower limit is u equal to x squared, or u equal to 1 squared is 1. The upper limit, u equal to 3 squared is 9. And now we have, all right, we need du. Now du is 2x dx, so 1/2 du, all right, 1/2 du divided by square root of u squared, not u squared, u plus 1.20 squared. Okay, after the substitution, this is the integral we have. W equals 25 newtons times 1/2 du over u plus 1.20 squared. Now, in the front of your text, the very front flap of the book, we have the integral of dx. Oh, I don't need integral tables. Sorry. Okay. Now we have du over u plus squared over u plus 1/2 u squared. The integral of that is, let me just go ahead and pull out the 25 newtons over 2. The integral of 1 over u plus a constant is square root of u plus a constant is u plus 1.20 squared to the 1/2 u plus 1.20 squared to the 1/2. All right, so if I take the derivative of this, I'm going to get 1/2, and so it's going to be twice this. All right. Okay. So if I take the derivative of u plus 1.20 squared, I get 1/2 of u plus 1.20 squared to the minus 1/2, which is what we have here. That 1/2 multiplied there cancels out the 2. We get all happy here. And so now we have 25 newtons onto, all right, and we need to evaluate the limits. So we've got 9 plus 1.20 squared. Let me just put a square root out front. See if it picks up on that and parses it correctly. Nope, it does not. Okay, square root of 9 plus 1.20 squared minus square root of 1 plus 1.20 squared I messed up my brackets. I don't know if I can fix that. Let me see if I can fix it on this end. Nope. Alright, you guys are going to have to put up with the brackets being messed up. Unless, I could do this. Now I can fix my brackets. Okay, so 9 plus 1.20, 25 newtons times square root 9 plus 1.2 squared minus the square root of 1 plus 20 squared, and I get 41.7 joules. Okay, I believe that's it for this problem.